Hello, I'm Paul Hutton, editor of Smart Highways magazine. We're just getting ready to show you another session from JCT Traffic Signals Symposium 2018. But before, let me just remind you of a few things. First of all, if you're at JCT this year or are affiliated to the organisation, you can sign up for a free copy of Smart Highways magazine. Just go to the link at the bottom of the screen. Also, mark your cards for the ITS UK Summit, 26th and 27th of November at the Bristol Harbour Hotel. It will be a fantastic day talking about implementation. And next year, don't forget, Trafex, 2nd to 4th of April. It is the biggest and best Trafex yet. Don't miss it.
He's an electrical engineer by trade, worked for HETS in the 1980s. He's worked for loads of other authorities. He's worked for Leeds, he's worked for Wakefield, but he now works for Kirklees. He's currently group engineer at Kirklees, and I know that he does absolutely everything. Scoot, mover, I mean, you name it. He's all over it. He's very, very hands-on, but he's got a very unenviable task at the moment. He's actually trying to get all 5 West Yorkshire UTC teams into one unit. Good luck with that. So, without any further ado, I'm going to ask Dave to come and deliver his paper, Kirklees laying the foundations for focused air quality-based vehicle control. Thanks, Dave.
Cheers, John. Hi, good afternoon. My name's Dave. I'm Group Engineer Kirklees. I'm by no means an expert on air quality. I am a traffic signals engineer and give me red, amber, green every day. It's been a steep learning curve, but it's a curve that we've had to, it's a learning curve that we've had to take, because in West Yorkshire, as with many other areas around the country, we're under the cosh, especially with air quality. It's becoming more and more prevalent. It's becoming more and more of a political hot potato, and all our lead members and all our combined authority, they are extremely worried about the implications for charging zones and for air quality zones, low emission zones. They are politically unpalatable, to say the least, with the public. They know what we've got to have them, but politically it's a nightmare. And so my project, or the survey that we did, was trying to work out another way of proving which of the most efficient ways are operating traffic signals, and trying to prove that using virtual means, not by using our technology out on street, by trying to use data that's already out there that we all use. We all look on Google Traffic, we all look on as apps for weather and things like that, and there will be coming a time when we won't have our technology out on the street, so we've got to take that leap of faith sooner rather than later, and we might as well start that progression now. And the more confidence that we get in these systems, then we can drive that as a customer, and people then will work on these systems and make them more and more efficient. So, no, that's that one. Which one's that? I'll go the old way. So, we had a particular problem in Huddersfield, and the problem that we had a junction at Leeds Road, Bradley Road, which is just to the east of Huddersfield. It's near junction 25 at M62, a very, 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 very busy junction. It was declared in an AQMA zone, and we had 54 properties within that zone, within that particular zone. It runs fixed time for 24/7, 7 days a week, and a very, very, very busy junction. AM peak starts roughly between 6:30 and 6:45, and runs on mainly till about 9-ish. With its proximity to the motorway and our proximity halfway between Leeds and Manchester, then we have an early peak when it starts, when people are travelling to and from the motorway, and then we have a local peak where we've got people coming in towards Huddersfield and Bradford and areas like that. We switched from fixed time to scoot when it was declared an AQMA, and that was done in 2013. Obviously, we had to have a plan once we declared an AQMA, and we did that. The measurements we're getting were a 31% reduction in emissions when scoots in use against fixed time. Now, I'll explain that to you in detail later on, because this junction's got some particular, how can I say, it's got a lot of heavy goods vehicles within it because of its proximity and all the businesses that were in it. The VM that we've currently got, where it's provided through Denique, that's still in place. It's gathering information, and we'll log on to that. And if anybody wants to look at it, I'll give them a link, and I'm sure Denique will give them a password, and they can have a look at that and look at the dashboard if they need to. So, how does the virtual emissions monitoring work? So if you look, it looks like that. It gets feeds, so we've got feeds, virtual feeds from Highways England, because it's proximity to the motorway. We get fleet data that comes from DFT. We've got Bluetooth sensors all on all approaches. We get Datex2 historical feed from thing. We've got Scoot, we've got Midas, automatic traffic counters, DFT fleet statistics. We've got Met Office. We've got several different feeds into the emissions algorithm. Now, the algorithm that they use is the Copert model, the DEFRA Copert model, which is typically an EEC model that likes conformity, straight roads, uniform speeds and everything like that. That's how there are no gradients, no turns, and obviously all our roads that's out there, we know that's not the real world. So, this is the junction in position. These are the links. So if you look, let's see if I can do this. So, these are the links. This is the main A62 coming in from junction 25 in towards Huddersfield. This one comes in from junction 24 from Halifax. This one here, this road here, a B road. You think, it's only a little B road. It is, but it joins to junction 38 at M1. Now then, for us, that means all this triangle here, if anything happens on the M62 between junctions 25 and 29, and on the M1 between junctions 42 and 38, that becomes the M1 and the M62, because they all go across country. So for us, it gives us particular problems. It runs Scoot 24 hours a day. It's just a four-stage junction, just a typical four-stage junction, main road inbound right turn, side roads, and an early cut-off. Now, the early cut-off on a morning peak has got over 1,100 vehicles on that right turn, so it's a significant right turn because it takes you straight to the motorway. Now, then it did run on a filter link, but what we've done some fancy work where we've got congestion monitoring via SAPs, and we actually turn it into a normal link when it's not too congested, when it's congested on side road and not on the main road. So obviously we don't want to affect what's happening on A62. That turns in and out, and typically on a morning peak we can get up to 34 seconds on a right turn green arrow. So as you can tell, it's a bit busy. When it drops off Scoot, my phone's red hot, social media gets red hot, we get a lot of complaints. So we tend to know when there's something wrong. So if you look at all of these links are the VEM links. There's 23 in total. And if you look on some of them, there's a right little one there. It doesn't show it there, but that one there is about 10 metres in length. It's on a little left turn as you're approaching that takes you towards Huddersfield. So these are the links. They're the movements, as you can see. It's just, they're basically a repeat of what they have. But that link there right at the bottom is, I think that's 23. That's the one, that's the short link. That one there. So as you can see, it is a big junction. It is busy. It's busy all the time. And it's just one of them. It just keeps running and running and running. So these are, what we did then is we decided that when it went into an AQMA, after 4 or 5 years now, our air quality people have now told us that there is only 2 properties now in that AQMA. One's the White Hart pub smack outside at controller. One is the property outside of it. So we've taken about 50 properties out of that AQMA. Now, they asked why we'd done it, and I tell them, well, it's schooled. It's got to be schooled. That's the only thing we've changed. So then the challenge that I got was, well, prove it, which becomes a bit more difficult then. So that's why we went for the VEM. So we thought, well, how can we prove it's schooled? So what we did, we put fixed time back on. So we ran fixed time, the old fixed time plans for a month. And we had a quick look at the plans. The morning peak plan were not very brilliant. So we gave a little bit more time on right turn green arrow just to keep the complaints away, because they would have come. So we thought we just massage that one just to keep them quiet so they'll not know. We could tell when we were going through the junction because obviously the queues had changed and there were a few more stops, a few more starts. So after that month, we put school back on, no problem. Then we started looking at the data that we'd got. And if you look at the data there, the data shows, the orange data it's static. That's the emissions that come from static, when vehicles are static at the stop line. Blue is coming from accelerating and moving traffic. It was difficult to try and separate accelerating and moving, so we just put it all in together. And as you can see, it follows a pretty much pattern. But then what we saw is this is over a 2-day pattern. If you look, there's a couple of little spikes there. And we couldn't really understand what they were. Then when we looked into it, that's one of them. That's the other. So it does pick it up. It picks it up very, very, very quickly. And basically, this is what you get. You get a dashboard with a VEM. Most of the time that we're taking up, we're developing this dashboard. So if you look at them, that's the typical, you'll get that. That tells you what currently that junction is emitting in NOx. So it's a nitrous oxide problem that we've got at this junction, not a particulates, it's just straight NOx. So that tells you what your uniform flows in. That tells you what they are. That tells you we're monitoring congestion on the Highways England network. We've got a zone network. And then what we do for each approach, and I think we should have had that one up front, but each approach has a little dial. So you know which part of the junction is actually not performing well. So you can tell whether there's a problem on A62, whether it's on side roads or on other side road. Now, you can have, if you had this product or whatever, you can have that dashboard how you want. You can have it up on a big screen, you can have it there all the time if you want. It's completely how you want it. We liked it like that, and that's what we stuck with. So, what's our next steps? Now, the next steps for us is we'll just continue monitoring the survey site. Danica are quite happy, and the West Yorkshire Combined Authority are quite excited about all of this, and what they're looking is to roll it out to nearly all the junctions in West Yorkshire, because now we've got the feeds. Once you've established the feeds, it's only about putting markers on the map, because all it does then is you get in the existing feeds, because they're all virtual, and it's all then done by fancy GIS mapping and stuff like that. So Calderdale, who are our next door neighbours, they're actively looking to put this in some of their sites. They've got air quality monitor sites. The rest of West Yorkshire, they're looking to do that as well. And not only of that, for me, the next steps are, there's two next steps for me. The next step is what we're currently doing. If we look there, we're reacting to air quality. We're not being proactive. What I want to be able to do currently, we all optimise for congestion with school. We do other things, buses and stuff like that. But when that goes in that red there, I want to be able to turn that back into an acceptable level, and I want that to then drive my scope parameters to do that, to deliver that. Now that's being reactive. What we want to be is proactive. So we're currently working with Huddersfield University and their Professor of Artificial Intelligence, who are very, very interested. and Danique as well. And what we're looking to do is use artificial intelligence or machine learning or whatever you call it to actually say, well, actually, Dave, in 4 hours' time, you're going to have an instance. And we predict, if looking at the Met Office statistics and looking at the current flows and looking at the vehicles and stuff like that, then we think that you will have an instance in 4 hours' time. So we need you to alter your signals now to best limit that instance. So that's the way for us. We feel that that's the next steps for us. Yes, fair enough, it'd be nice to turn that dial and it work, but really and truthfully, what we should be doing is it stopping it happening the first time. So that's the next steps with us. And like I said, we've got some very, very brainy people at Huddersfield Uni, a lot brighter than we'll ever be, unfortunately. And they are chomping at the bit, should we say, to start with it. So this is what they're looking for, predictive models, algorithms, all of these things that feed in, shopping, you know, all of that, all into artificial intelligence. And then what they want to do is they want to be able to develop strategies that drive our signals and predict and try and stop that stopping in the first instance. Now then I'll come back now to our results. Why did we get 31%? It were a total shock to us. DFT statistics for Leeds Road or for West Yorkshire shows that last year normal HGVs as about 1.6% of the makeup of traffic. On that route, it's 2.3 miles long. It supports 500 plus businesses within 100 yards of that road, some real business. So with 6% of heavy goods vehicles. So we found out that, yes, we got 31%. It shocked us, reduction in NOx. But we were expecting somewhere in the low teens. But it just shows if you've got junctions that are really busy with heavy goods vehicles, we wouldn't have an air quality problem if there weren't so many vehicles, so many air quality vehicles. So it's chicken and egg. So yes, we did get a 31% reduction in NOx. I'm not saying you get that at every location, but for us, it's a winner. You know what I mean? And our politicians, they love it, and it is gaining more and more importance within the combined authority. So what I would say is if you want to have a look at the VEM, by all means contact me. I'll see if I can get you to log in and just have a look at it at your leisure.
Fantastic. Thanks, Dave. Questions for Dave? One here, please. Tom?
Tom Siddle for Wake Consulting. What steps have you taken to actually prove the accuracy of the model? You know, have you had NOx measures taken out?
We've got a fixed AQMA outstation not 200 yards from that location, and yes, they did see significant drops. Obviously, it's not smack at the junction where we were modelling, but on Leeds Road, just 200 yards from there, they saw a significant rise in air quality when we were and poor air quality, a rise in NOx of above 20% on that approach. So it were validated, yeah. And I know it's a leap of faith, and it's got to be a leap of faith. We all look at it as apps. We all believe as apps. So why shouldn't we believe information that's coming from all of that's out there at this moment in time?
Any other questions? Yeah, one behind you, Stuart.
Hi, Joe Birdside, Transport for London. Our system has a scoop system, attempts at predicting what the emissions of vehicles are. I don't know if your system does this.
Yeah, it does, but it don't do it very good.
Okay, so I was just going to ask, have you looked at the correlation between what your
system... Yeah, we looked at ours as a unique integrity, and obviously what it does is you have to put the makeup of vehicles in, but it's just the makeup of vehicle at that time. And so you're taking a broad brush approach of what you think it is at that time. Obviously, you know and I know, Bluetooth and everything like that, certain times a day, we use DFT fleet statistics and other fleet statistics. Heavy goods vehicles travel at different times a day. And so we did look at that through the unique integrity, and we decided, well, actually, no, it's not fit for purpose. That we don't think it is anyway.
Okay, thanks.
Any more? Dan's got one, please.
Hi, Dave.
Dan.
Dan Priest, Integrated Traffic Services. Did you consider any special vehicle detection and giving freight vehicles priority under scoot to see if you could further? I mean,
No.
The results are outstanding, but do you think you could get?
No, only thing we've got is bus priority on there, Dan. Now, we have used the RTM stuff before that we're profiling vehicles, but we didn't use it for this trial, you know what I mean? We probably look at that next, so that if we do see a build-up of heavy goods vehicles, you know what I mean, then it is an option, but no, we didn't. Only thing we do have is bus detection on all them approaches.
Transport for Greater Manchester are doing an R10 trial under scoot, so I mean, it'd be
Yeah, well,
if we could share a bit of data with you.
we got this idea from TFGM. TFGM tried it just before us. Now, they tried it in Richard's people. They tried it, and we saw that trial, and we thought, well, we can just manipulate it just for this junction, you know what I mean? Because what we got in West Yorkshire, we have a lot of people that don't like scoot. We still have, you know what I mean? And that's changing, and I see a couple of people laughing up here, and we need to prove to people that it does change things, you know what I mean, against fixed time. And obviously, every junction's got its own method it works best. It could be scoot, could be move, it could be fixed time, could be anything, you know what I mean? But it's just, when we do run scoot, we know what the benefits are now. We can quantify that.
Any more? Well, can I make a tongue-in-cheek one?
Yeah,
You said that you were left with 2 buildings that were in the AQMA and one was the pub.
yeah.
Did you think about compulsory purchase order in the pub and putting a signal round about him with the extra land?
There's a railway tunnel run smack underneath it, John, we can't.
I knew that. I thought there might be a reason. Let's thank Dave again.